This should be a quickish section, but it's still going to probably be 45 minutes. We're going to add, subtract, multiply, and do something called scalar multiplication of matrices, just some basic matrix operations. And to get started, each of the 24 problems in this section calls out one or two of these matrices. So I'm going to enter each one of these on my calculator in the appropriate letter. So I'm going to start off and enter matrix A now as a 2 by 2 matrix. This matrix A has nothing to do with a system of equations. I can't use it to solve for x or solve for y. It just is what it is. It's just a table of numbers that doesn't have any context at this point. So I have matrix A in -2, 4, 3, 1. I'm going to go on and enter matrix B, which is another square matrix, so I could find its determinant if I care to. It's a 2 by 2 matrix. I'm going to go second matrix, arrow over to edit. Now go down to B, then hit enter and type, I already have it entered, 4, enter, 5, enter, 1, enter, 2, enter. Then second and quit, then second in matrix over to names, down to C. C has 1, 2, 3 rows and 1, 2, 3 columns. So C is going to be a 3 by 3 matrix. My best guess is I already have it entered in. 3, enter, 3, enter, 1, 0, -1, 7, 2, 4, 2, 3, -5. I entered these in the first time I recorded this video, then I had some quality issues, and so they're already probably all going to be in my calculator, but you can take the time to enter all of these. D is going to be another 3 by 3 matrix. It has 3 rows and 3 columns. So once I'm done entering C, I'm second quitting, and then second going second with the up arrow here, hitting the matrix key, going over to edit in the right hand column, down to D in the left hand column, and D, I changed D for some reason. D is supposed to be a 3 by 3 matrix, which has 3, 2, 0, 4, -1, 3, and then 1, 5, 1, -5, and 6. So getting all the matrices in accurately is a big deal. If you enter them wrong, all of a sudden your calculator won't match up with what we do by hand. Quit out of this, move on to matrix E, and matrix E has 1, 2 rows and 1, 2, 3 columns. Matrix E is going to be a 2 by 3 matrix. I've definitely changed that. 2 by 3, -3, 2, 2, 5, -1, and 3. Second quit, and the last matrix F, it has 1, 2, 3 rows and 1, 2 columns. Matrix F is a 3 by 2 matrix. Second matrix edit, go down to F, 3 by 2, 1, -2, 5, 2, 6, 7. So get all these matrices in your calculator. Pause the video if you need some more time to do it. And I'll do everything on my calculator and by hand. Problem 2, this is called scalar multiplication. When there's a number written to the left of a matrix name, that number gets multiplied by every number inside the matrix. So matrix F has 1, -2, 5, 2, and 6 and 7 inside of it. To get my answer, to do -2 times matrix F, I'm going to multiply each number by -2. So I'm going to go -2 times +1 and get -2. -2 times -2 and get +4. -2 times +5 and get -10. -2 times +2 and get -4. -2 times +6 and get -12. -2 times 7 and get -14. That should be the answer to problem 3. I don't know why I just did problem 3, but I did. I might even thought it was problem 2, but because of the 2 there. Let's go ahead and check this real quickly. Super easy to check. I just need my calculator to basically display that. I'm going to get my calculator to have the number -2 followed by the matrix F, and I can do all this using the matrix names. I don't need to do RREF. I don't need to do DET. I'm first going to type the number -2, and then second matrix, and under the names column, go down and tag the F and hit enter. So there's the negative 2f that was represented in the problem. Once I hit enter a second time, should get that answer. So negative 2, 4, negative 10, negative 4, negative 12, negative 14 feels good. I'm going to do problem 2, which is 5 times matrix B. 5 times matrix B is called scalar multiplication. I've just replaced the symbol of B with what B is equal to. Now I'm going to multiply each number in that matrix C by 5, and that's going to be my answer. Again, I'm not getting x equal to a number or y equal to a number. This is not a matrix that represents a system of equations. So 5 times 4, 20, 5 times 5, 25, 5 times 1, 5, 5 times 2, 10. Claim that's the answer to part 2. Let me go ahead and check this by typing the number 5, and then second matrix, go down to the matrix B and hit enter. There's my calculator's representation of 5B. And now when I hit enter, I see 20, 25, 5, and 10, so I feel perfect about my answer. So give number 1 a go. I did number 3 already. 5 and 6 is matrix addition. Let me show you how to do it by hand. It's pretty easy. 6 wants me to first write down matrix C, which has the columns 1, 7, 2, 0, 2, 3, minus 1, 4, negative 5. Then toss down a plus sign, and then put down matrix D, which is 3, 2, 0, 4, negative 1, 3, 1, negative 5, 6. To do matrix addition, you just add the numbers that are in the same spots. So in the upper left-hand corner, I'm going to add 1 and 3. And in my answer, in the upper left-hand corner, I'm going to have a 4. I probably could show a little less work than I'm showing, but maybe for the first time I'll show a bit of work. The next thing in the top row is going to be 0 plus 2. And 0 plus 2 is going to be 2. And then the last thing in the top row, I'm going to add negative 1 and 0, which are in the same spots. And negative 1 plus 0 is negative 1. I'm going to move on to the next row. Second row, the first thing I'm going to do is add 7 plus 4 because they're in the same positions. That's going to give me 11 as the first number in the second row. Then I'm going to add 2 plus negative 1. The negative I'll put in a parentheses, and when you're adding numbers with opposite signs, you're really subtracting. That's going to be positive 1. And then last thing in the second row is 4 plus 3. 4 plus 3 is 7. Now move on to the bottom row. First numbers in the bottom row I'm going to add are 2 and 1, because they're in the same position, and I'll get 3. And then 3 plus negative 5. 3 plus negative 5, since they have opposite signs I have to subtract, I'll get negative 2. And then negative 5 plus positive 6. Those have opposite signs, I subtract, and I'll get a positive 1. I claim that's the answer to problem 6. Let me real quickly do C plus D on my calculator. Easy enough to do because I just have to use the matrix names for all of these problems. So first, second matrix names C and hit enter. And then the plus sign that's between them. And then second matrix names D and hit enter. So that's my calculator's version of C plus D. When I hit enter, I see 4, 2, negative 1, 11, 1, 7, 3, negative 2, 1. So my answer is correct. So give number 5 a go. You should be able to check these real quickly too. Eight's a combination of scalar multiplication and addition. So first, I'm going to rewrite the problem without the letters, replacing the numbers with the matrix symbols, or the matrix itself, should I say. So 2C plus 6D is this as a problem. Now I'm going to find out what 2C is by taking each number in the C matrix and multiplying it by 2. So I'll go 2 times 1, 2 times 0, 2 times negative 1. 2 times 1 is 2, 2 times 0 is 0, 2 times negative 1 is negative 2, 2 times 7 is 14, 2 times 2 is 4, 2 times 4 is 8, 2 times 2 is 4, 2 times 3 is 6, 2 times negative 5 is negative 10. So you do scalar multiplication before addition. Second matrix, multiply every number by 6. 6 times 3 is 18, 6 times 2 is 12, 6 times 0 is 0, 6 times 4 is 24, 6 times negative 1 is negative 6, 6 times 3 is 18, 6 times 1 is 6, 6 times minus 5 is minus 30, 6 times 6 is 36. Now I'm just going to add the numbers and I'm going to get my answer. I'm going to try to just write the answer down. My calculator is going to fix me if I make a mistake. So first addition, 2 plus 18. I'm just going to write 20 down because 2 plus 18 is 20. Second addition, 0 plus 12. 0 plus 12 is 12. Third addition, negative 2 plus 0. Negative 2 plus 0 is going to be negative 2 because 0 plus any number is that number. Done with the top row without any really large numbers. First thing in the second row, 14 plus 24. I believe that adds to be 38. And then 4 plus negative 6. When I go to do 4 plus negative 6, those have opposite signs, so I subtract, take the sign of the larger and get negative 2. And then 8 plus 18 to end off that middle row, and 8 plus 18 is 26. Bottom row, first addition, 4 plus 6, which is 10. Next addition, 6 plus negative 30, and 6 and negative 30 have opposite signs, so I have to subtract those. 30 minus 6 is 24. That should be negative 24 because the bigger number is negative. The last, negative 10 plus 36, I believe is positive 26 again. I'm going to do this whole problem on my calculator by entering that in my calculator, and I'm going to check every entry to make sure I haven't made a mistake. If I've made a mistake, I'm just going to just cross it out and write the right number. So on my calculator, I'm only using the names for the matrix part. So I'm going to do 2, then second matrix, name C, plus 6, second matrix, names D. So there's 2C plus 6D, hit enter, 20, 12, negative 2, 38, negative 2, 26, 10, negative 24, 26. So I feel completely fine about that. Ten and 9 are scalar multiplication and subtraction. Let me do 9 because it's a lot shorter. So I'm going to do your number 9. You can pause the video and give it a try if you think you know how to do it. So I'm going to rewrite number 9 without the letters. I'm going to change the matrix A to what it's equal to. Put the minus sign and change the matrix B with what it's equal to. For the first matrix, I'm going to get 3 times negative 2 in the upper left-hand spot, which is going to be negative 6. For the second matrix in the upper spot, I'm going to get negative 2 times 4, which is going to be minus 8. So for the first entry in my answer, I'm going to get negative 6 minus 8, and part of my answer is going to be negative 14 in the upper left because that's what negative 6 minus 8 is. Second position in the top row, I get 3 times 4, which is 12, and then negative 2 times 5, which is minus 10. So this is going to give me a 12 minus 10, which is going to give me a 2. So I'm kind of trying to shorten up the work because I don't think it's that hard. Bottom row, first multiplication, 3 times 3 is 9. Bottom row, second matrix, first multiplication, negative 2 times 1 is negative 2. That gives me 9 minus 2 is 7. Last number, 3 times 1 in the left matrix gives me 3. In the right matrix, negative 2 times 2 gives me negative 4. Let's move with 3 minus 4, which is negative 1. believe that's the answer. I'm going to enter that on my calculator and make sure that matches up. So on my calculator, clear 3 first, and then second matrix names A and enter, and then the minus sign, and then the number 2, and second matrix names go down to B and hit enter. There's 3A minus 2B, hit enter, negative 14, 2, 7, and negative 1. So I did perfectly. So I kind of crunched the work a little bit, but hopefully it wasn't so bad. If I move down to problem 12, it wants me to take matrix B, which is 4, 5, 1, 2, plus matrix D, which is 3, 2, 0, 4, negative 1, 3, 1, negative 5, 6. Bad things happen here because this matrix is only 2 by 2, and the 2 by 2 part of the D matrix is there. There's all these stray numbers that don't have any number to be added with. This is going to be not possible. We can just say there's no solution, or you can't add these. You can only add matrices if both matrices have the exact same dimensions, if there's a one-to-one correspondence between each piece. When you have these stray pieces that don't match up, those matrices can't be added, or in this case they can't be added. And on my calculator to do this, if I did second matrix B plus second matrix D, again that's my calculator's version of this problem, it's going to give me an error message. My calculator knows that these can't be added. I think it says dim mismatch, which means dimension mismatch. This is the dimension of this matrix is 2 by 2, the dimension of this matrix is 3 by 3, and in order to add matrices, the dimensions have to be the same. So when I hit enter, I think I get dimension mismatch, and those just can't be added. I'm just going to second and quit and know that I can't do that. For problem 14, E is a 2 by 3 matrix. F is a 3 by 2 matrix. If I try to add those, I'm going to get a dimension mismatch again, because in order to add matrices, the matrices have to have the exact same dimensions. Wouldn't even really have to write anything down other than not possible for an answer, or no solution, I guess. So for my answer to this, because these don't match up perfectly, these 4 match up with those 4, but those 2 don't match up with those 2, so those can't be added. Again, my calculator's going to know this. For an answer, you could write no solution, or you can write not possible. If I do the same thing on my calculator, do second matrix names E plus second matrix names F, and then hit enter, my calculator gives me that error message. All right, so then we've done addition, subtraction, and scalar multiplication. We don't do division with matrices, so the last thing we have to do is traditional multiplication. And matrix multiplication is very bizarrely defined. I'm not really sure why it's defined how it is, because I haven't done a lot of work with matrices in my career. I had a whole class on matrices, linear algebra, math 342, but we didn't do much matrix multiplication. Let me do 16 by hand. I'm going to replace the matrix B symbol with 4, 5, 1, 2. I'm going to replace the matrix A symbol with negative 2, 4, 3, 1. Those are the same dimension. B is a 2 by 2 matrix. A is a 2 by 2 matrix. It turns out for matrix multiplication to be possible, these two numbers need to be the same. They don't have to be the same dimensions. You can multiply matrices with different dimensions, as long as the number of columns in the left matrice is equal to the number of rows in the right matrix, you could do that multiplication. Let me do this on my calculator to make sure I don't mess up. So on my calculator, it's not particularly hard. I go second matrix, go down to B and hit enter, and then second matrix, stay at A and hit enter, and then hit enter again. My answer is 7, 21, 4, and 6. To get there, it's bizarrely defined. I'm going to first get the top row. And to get the top row, I use the column of the B matrix, the row of the B matrix, and the columns of the A matrix. What I'm going to do to get the top row, the 7 and the 21 in my answer, is I'm going to take the top row of the B matrix and write it as a column. So that 4, 5, that's a row. I'm writing it as a column. I'm going to put a times sign, and I'm going to first write it next to the first column in the second or the A matrix, and then I'm going to write it next to the second column in the A matrix. So I use the top row of the B matrix to get the top row of my answer. I write it as a column next to each of the columns in the A matrix. Now I'm going to multiply and add. I'm going to go 4 times negative 2 is negative 8. 5 times 3 is 15. And I'm going to add those, but because they have opposite signs, it's really subtracting. I'm going to do negative 8 plus 15 and get positive 7, which is the first number in my answer. So there's the first computation that I needed. Second computation, multiply across. 4 times 4 is 16. 5 times 1 is 5. Add those numbers together. 16 plus 5 is 21. That's the second part of my answer. Now I'm going to move on to get the bottom row in my answer by using the bottom row of the B matrix. And I'm going to do exactly the same thing that I did with the top row to the bottom row. So I'm going to take the 1, 2 and write it vertically as a column next to the negative 2, positive 3 row. And I'm going to take the 1, 2, write it as a column next to the 4, 1 column, should I say. Now I'm going to multiply. 1 times negative 2 is negative 2. 2 times 3 is 6. Adding negative 2 plus 6, because they have opposite signs, I subtract and get a positive 4. And the last part of my answer, I'm going to go 1 times 4 is 4. 2 times 1 is 2. Add these and get a 6, and there's the 6 in my answer. So the 4 things that I have boxed are the 4 components of my answer, the 7 and 21 in the top row, the 4 and the 6 in the bottom row. So you should find out what the answer is for 15 before you do 15. On the next page, let me do 17 with you. So you can pause the video and try to do 17. I'm going to get an answer for 17 real quickly so I know what I'm targeting. So second matrix names F, and then second matrix names A. And apparently the answer to problem 17 should be negative 8, 2, negative 4, 22, 9, and 31. That's just mindlessly pressing buttons. Matrix F is a 3 by 2 matrix. Matrix A is a 2 by 2 matrix. These matrices can be multiplied. They're not the same dimension, but I just need these numbers to match up, meaning the number of columns in the first matrix equals the number of rows in the second matrix. Let me write down this without the letters. So for matrix F, I'm going to write 1, negative 2, 5, 2, 6, and 7. And for matrix A, I'm going to write down negative 2, 4, 3, and 1. First, I'm going to get the top row. Then I'm going to get the middle. And then I'm going to get the bottom. Because in my answer, there's a top row, middle row, and bottom row. To get the top row, I use the top row of F and write it down as a column next to the columns of A. So I'm going to write 1, negative 2 times the first column, negative 2, 3, and then write that again as a column, 1, negative 2, multiply it by 4, 1. First one, 1 times negative 2 is negative 2, negative 2 times 3 is negative 6, negative 2 plus negative 6, because they have the same signs, I add them and keep them negative and get negative 8, which is the first number my calculator gave me. Next multiplication, 1 times 4 is 4, negative 2 times 1 is negative 2. These numbers have opposite signs, so I subtract them. 4 minus 2 is going to be 2. This is now the top row of my answer. So the top row of my answer has negative 8 and positive 2. Done with the top row, moving on to the middle row. I'm going to take the middle row and write it as a column. So I'm going to write 5, 2 as a column and write it next to negative 2, 3. I'm going to take 5, 2 as a column and write it next to 4, 1. And then I'm going to multiply across. 5 times negative 2 is negative 10. 2 times 3 is 6. When the numbers have opposite signs, you subtract. Take the sign of the larger. Negative 2 plus 6 is negative 4, which matches up with that, negative 4. Next one, 5 times 4 is 20. 2 times 1 is 2. 20 plus 2 is 22. Well, I just did that in that color, but there's my middle row of negative 4 and positive 22. On to the bottom row. For the bottom row, I'm going to take this 6, 7 and write it as a column. So I'm going to write 6 and 7. I'm going to write it next to negative 2 and 3. And I'm going to take 6 and 7, write it next to 4 and 1. Multiply. 6 times negative 2 is negative 12. 7 times 3 is 21. Now I'm doing negative 12 plus 21. And negative 12 plus 21 is equal to 9. So 9 is the first number in the bottom row. And then the next multiplication, 6 times 4 is 24. 7 times 1 is 7. Add and get 31. And so these are the numbers for my bottom row, 9 and 31. All right, not too many more problems. Our problems, 19 and 20 are bad because I use the C and the D matrix. I'll do 20, you can do 19. So for 20, I'm going to write the D matrix. 3, 2, 0, 4, negative 1, 3, 1, negative 5, 6, followed by the C matrix, 1, 0, negative 1, 7, 2, 4, 2, 3, negative 5. D is a 3 by 3 matrix. C is a 3 by 3 matrix. Since these two numbers pair up, I can do the multiplication. Let me do this by hand and then get my answer. So I'm going to shoot for the top row in my answer. The top row in my answer, I take the top row and multiply it by each of the columns. So I'm going to take that top row and write it as a column. So I'm going to write 320 next to 172. Then I'm going to take 320 as a column, write it next to 023 with a little time sign between, and then 320 times negative 1, 4, negative 5. I'm going to multiply. 3 times 1 is 3. 2 times 7 is 14. 0 times 2 is 0. That's going to give me 17. And so as I go to write an answer, I don't have so much room here. I don't know how well it's going to fit. But my answer, the first number that I'm going to write in the top row is going to be the number 17. Moving on, the next multiplication, 3 times 0 is 0. 2 times 2 is 4. 0 times 3 is 0. Add those numbers up and get 4. That's the second number in my top row. Last multiplication for the top row, 3 times negative 1 is negative 3. 2 times 4 is 8. 0 times negative 5 is 0. When the numbers have opposite signs, you subtract them. 8 minus 3 is positive 5. That's the end of the top row. In my answer, the top row is going to be 17, 4, and 5. Now I'm going to move on to the middle row. Using the middle row. So I'm going to take this 4, -1, and 3 and write it next to each column. So 4, -1, 3 times 1, 7, 2, and then 4, -1, 3 times 0, 2, 3, and 4, -1, 3 times -1, 4, -5. First, 4 times 1 is 4, -1 times 7 is -7, 3 times 2 is 6. That's 4 minus 7 plus 6, which is 3. Second, 4 times 0 is 0, -1 times 2 is -2, 3 times 3 is 9. This is really just 9 minus 2, which is 7. Last multiplication, 4 times -1 is -4. -1 times 4 is -4. 3 times -5 is -15. This is -4 minus 4 minus 15. Or you could say -4 plus -4 plus -15. That will work. Or -4 minus 4 minus 15 will also work. They both give you -23. So 3, 7, -23 is the middle row of my answer. Done with the top row, done with the middle row, on to the bottom row. For the bottom row of my answer, I have to use the bottom row of the matrix that's written first and write it as a column. So I'm going to write 1, -5, 6 next to 1, 7, 2, and then 1, -5, 6 next to 0, 2, 3, and then 1, -5, 6 next to -1, 4, -5. Multiply 1 times 1 is 1, -5 times 7 is -35, 6 times 2 is 12. Need to go 1 plus -35 plus 12, and I'll get -22. Next bit, 1 times 0 is 0, -5 times 2 is -10, 6 times 3 is 18. That's going to give me a positive 8 because that's just 18 minus 10. Last one, 1 times -1 is -1, -5 times 4 is -20, 6 times -5 is -30. That's technically -1 plus -20 plus -30, and I get -51. I could have just done -1 minus 20 minus 30 and still got that -51. So the bottom row in my answer has a -22. You can't even see my whole answer here. Has a -22, a positive 8, and a -51. It's a mess. It's just tedious. And let me do DC on my calculator to make sure it matches up. So on my calculator now, second matrix names D, and then second matrix names C. There's DC. Hit enter. I see 17, 4, 5, 3, 7, -23, -22, 8, -51. So I did it correctly. Your 19 is going to be as ugly. Just have 2 more problems left, and they get easier. So 22 wants me to do matrix A, which is a 2 by 2 matrix, times matrix D, which is a 3 by 3 matrix. This is not going to be possible. The answer is either going to be not possible or no solution, because for matrix multiplication to work, the number of columns in the left matrix has to equal the number of rows in the right matrix. For my answer, I can write it's not possible, or I can write no solution. Then both would be okay. And I'll show you what happens when you do this. So if I write matrix A down, which is -2, 4, 3, 1, followed by matrix D, which is 3, 2, 0, 4, negative 1, 3, 1, negative 5, 6. The first thing I want to do is get the top row of my answer. I'm going to take this and write it next to each of these columns. So I'm going to go negative 2, 4 times 3, 4, 1, and then negative 2, 4 times 2, negative 1, negative 5, and then negative 2, 4 times 0, 3, 6. You get this straggler of a number that doesn't fit, and when the numbers don't match up perfectly, we just say it's that operation's not possible. So on my calculator, if I wanted to do matrix A times D, I'd go second matrix names A, and then second matrix names D. There's A times D, and it's going to give me that same dimension mismatch error because it's not possible. When I get a dimension mismatch error, you can either write not possible or no solution. For your problem, matrix B is a 2 by 2 matrix. Matrix C is a 3 by 3 matrix. You're going to get the same dimension mismatch error as I got for 22 because the number of columns in the matrix written first has to equal the number of rows in the matrix written second for the multiplication to be possible. They don't have to be exactly the same dimensions, but those two numbers have to match. All right, last problem. 23 and 24. Let me do 23 with you. So 23, the first matrix is a 2 by 3 matrix. F has 3 rows and 2 columns. So F is a 3 by 2 matrix. E is a 2 by 3 matrix. This matrix multiplication is going to be possible because those match up. So let me try to do your problem 23. So I'm going to write F first. F is 1, negative 2, 5, 2, 6, 7. And E is negative 3, 2, 2, 5, negative 1, 3. Start off using the top row to get the top row. So in my answer for 23, the top row I'm going to go 1, negative 2 times negative 3, 5. And then 1, negative 2 times 2, negative 1. And then 1, negative 2 times 2, 3. So 1 times negative 3 is negative 3. Negative 2 times 5 is negative 10. Those numbers have the same signs, so I add them. Next multiplication, 1 times 2 is 2. Negative 2 times negative 1 is positive 2. Add those to get 4. Last multiplication, 1 times 2 is 2. Negative 2 times 3 is negative 6. Numbers have opposite signs, so I subtract them and get negative 4. So in for my answer, I'm going to get negative 13, 4, negative 4 for my top row. So negative 13, 4, negative 4. Done with my top row, moving on to my middle row of 5, 2. My middle row is going to give me the middle row in my answer. So this is what I'm setting up for now is the middle row. I'm going to take this 5, 2 and write it next to each one of those. So I'm going to go 5, 2 times negative 3, 5. 5, 2 times 2, negative 1. And 5, 2 times 2, 3. Multiply 15. 5 times negative 3 is negative 15. 5 times 2 is 10. Opposite sign, so I subtract and get a negative 5. Next multiplication, 5 times 2 is 10. 2 times negative 1 is negative 2. Opposite sign, so you subtract. Last, 5 times 2 is 10. 2 times 3 is 6. Same sign, so I add. That's going to be the middle row of my answer, which is going to be negative 5. And then 8 and 16. Done with the middle row, on to the bottom row. So I'm going to take 6, 7, write it next to negative 3, 5, then next to 2, negative 1, then next to 2, 3. First I get negative 18 and 35. Negative 18 plus 35 equals to 17. Next one, I get 6 times 2 is 12, 7 times minus 1 is minus 7, 12 plus negative 7 is 5, or 12 minus 7 is 5. Last one, 6 times 2 is 12, 7 times 3 is 21, 12 plus 21 is 33. Bottom row of my answer starts off with a 17, ends up with a 5 and a 33. So that's supposed to be the answer to 23, which is f times e. Let me do that on my calculator. So second matrix names f, and then second matrix names e. There's f times e on my calculator. When I hit enter, hopefully I match up perfectly. So negative 13, 4, negative 4, then negative 5, 8, 16, and then 17, 5, and 33. So I did perfectly. I don't really barely made a mistake in this video, which is really unusual. So that's everything that we're responsible for in this section. We just have a couple more sections to do of new material, and won't be any adding or subtracting or multiplying matrices in those.